Alright, so we're going to be going over the 20th question in the grind 75. This one is called majority element. So the problem description tells us that we are given an array nums of size n, and we want to return the majority element. The majority element is the element that appears more than n divided by 2 times. So just to give an example, if we have an array of size 7, n divided by 2, or 7 divided by 2, is 3.5. The decimal will get truncated, but the majority element will appear more than 7 divided by 2. So it'll appear 4 times. And the same is true for even numbers. So if our array is of size 4, then the majority element will appear 3 times. Okay, so the solution that came to my mind was something similar to this, where basically we make a hash map and make the key every element in the array and the value that counts, where each time we see that element, we add to its count. Then basically we just grab whichever element has the greatest count and we return that element. So my solution had this exact function, but it was not as clear and clean, and it didn't use the same Hashmap methods, which I will go over so that I remember to do in the future. So first off, we have to make our hash map of elements and their respective counts. I just kind of did this inside of this method right here. It would make a lot more sense and be a lot cleaner if we were to put this into its own function. And we can make it private because we're inside of this class, and so we can call that method from any method inside of this class, so we shouldn't be afraid of that. And then we get to here, and we use some fancy hash map methods that I should have known about earlier. So first off, we can get a key value pair by doing map.entry, and then kind of like how you would define the types for a hash map. So this is like a key value pair, or it's called an entry. And then another thing that I was concerned about was how do we loop over hash maps? I thought we weren't really supposed to be able to do that, but turns out we can by saying each entry in the hash map's entry set. So we can convert the hash map into a set, basically. And get key and get value are pretty great. So let's see. We can apply these methods on hashmap entries too. So we can, I guess a hashmap entry is essentially just a hash map of size 1, which we just refer to it as an entry, which is nice actually. I like it. And then, yeah, we return the value that we want at the end. And the time complexity of this is O of n because we have to iterate through the entire nums array, and then we have to make a constant time insertion into this hash map. And the space complexity is also O of n because there are, so in the nums array, n divided by 2 plus 1 of these elements are the same element. So a little bit over half of n's elements will be the same when we're adding them to the hash map, if that makes sense. It'll be the same element, so we'll just kind of be incrementing the count, so the space won't increase. But basically, that's n minus n divided by 2 plus 1, which is still n in the long run. So that's why our space complexity is n. It wouldn't be constant. Now, there's actually a way to reduce our space complexity to O of 1, and this algorithm is very short and honestly not super intuitive, but it's pretty cool to see it in action. So I'm going to get rid of this, And I'm also going to get rid of this just so we have the bare bones constructor, or the public method. So this one is called like it's a voting algorithm of some type. But basically, we're going to start out by iterating through nums. We're going to set the very first value to our candidate. And as we're going through nums, if we see a value that is our candidate, then we're going to cast a vote for it. We're basically going to add one to our count. But if we see a value that is not our candidate, then we're going to take one away from our count. And as soon as we get down to a count of 0, then we're going to update our candidate. We're going to change our candidate to the value that we're currently on. And this doesn't make a whole lot of sense up front, but I will actually switch over to Paint really quick to see how this kind of makes sense. This is sort of a simple example, maybe too simplified, but it should give you the gist. So the majority element needs to appear here, should be like that, needs to appear n minus 2, or n divided by 2 plus 1 times. So in both of these cases, n is equal to 7. So n over 2 plus 1 is equal to 4. And lucky for us, the number 4 also appears 4 times. So if we were to apply our method, we set the candidate to this and then cast votes for that candidate, then we'll increment by 1, increment by 1, increment by 1, increment by 1. It will be 3, but these values will not count towards our original candidate, and so we'll decrement, decrement, and then decrement once we get to here. And then, because we're at 0, we're going to reset our candidate. And basically, this will always work because the majority element will always have one more than any other value in the array. And so we will always, if you think about kind of like tug of war, even if the candidate value starts out as something else, the majority element value will eventually win the tug of war because it will have more votes, essentially. I guess you could think of it as like an actual election. So that's how that works, and let's just go over the implementation really quick. So I'm going to switch back over to the lead code window. So let's go. And so we're going to start out with integer count, initialize that to 0. Then we're going to have an integer called candidate. We can just set that equal to null. And then we're going to say, for int num in nums, if we come across a case in which our count is equal to 0, then we know we have to reset our candidate value. So we're going to set that equal to num. Then we can do the rest of the logic in a pretty clean and concise way by using a switch statement. And basically, we have to implement the vote casting section of this algorithm. So we will say if actually we can do this. So we're going to change the count, right? Because we're going to push the count up if the candidate is equal and push it down if it's not equal to our candidate. So we can say our current count plus equals if candidate is equal to num. And we're going to use the switch statement, which you can kind of think as if this statement right here is true, then return this value, else return this value. We could just as easily do this in an if statement, but this is just syntactically it's more concise. So this should work. Equal to num. Just going to make sure we don't have any syntactical issues. If candidate is equal to null. int candidate is equal to null. Why doesn't that work? We can just initialize it to 0. We know our array is going to be of length at least 1, so it will be updated. So we can just say that. That should work. Saying, oh, yes. We have to return our candidate once we've settled on it. And we've only really settled on it once we've gotten to the end of the array. Actually going to flip back to paint really quick. If we have this above example, even though we start off with 4, it keeps getting decremented once we move on to the next value and then reset. But eventually 4 will become the victor in the end, just because there are more of them. But we don't know that until we've gotten to the end. So I'm going to switch back. Okay. All right, and this should work. All right, and that has been the solution to the 20th problem in the grind 75. This has been majority element.